So let's begin with hashing. Introduction to hashing part 1. In this video we are going to see why the hashing is required. Okay, so the one of the main reason to use data structures is to store data. We all know this point. Fine. Now on any data structure, the most common operations that are performed are insert operation, search operation and delete operation. You know this point. Fine. Now in practical scenarios, search operation is widely performed. Okay, we insert the data, we delete some of the data from it, from our database, from our data structure, but we search a lot. So search in practical scenarios is used a lot. So we need to use a data structure in which searching is most optimum. Fine. So if we just see these data structures, what is the searching complexity for them? So in the case of unsorted array, the searching is in the time of order of n. Correct? We need to just linearly search. In sorted array, it can be log n using the binary search. Correct? In the linked list, it is order of n again. In binary tree, we have traversals, so their complexity is order of n. In the binary search tree, now in binary search tree, normally it is log n, but in the case of skewed binary tree, it becomes a linked list, and in the worst case, it again goes to order of n. Fine. In the case of balanced binary tree, because if they are height balanced, it is nothing but log n complexity like AVL tree. And in the heap, for finding minimum and maximum element, yes, it is order of 1. But for finding any other particular element, it is order of n. So as we can see, the search operation is only better in balanced binary tree or in the sorted array. Okay, and it is log n. Fine. So the best case scenario that we have right now is nothing but a log n approach for the searching time. Now to minimize the search time, hashing was introduced. Okay. What in the most of the cases, hashing gives us order of 1 search time. That is in a constant time we perform searching. Okay. So let's see, before going to hashing, something known as direct address table. Okay. So this direct address table was nothing but comes before hashing. So it uses a similar concept to hashing. Fine. And let's see what are its disadvantages and why instead of this now hashing is used. What direct address table says is, let's suppose we need 50 records. Okay, each record has a key to identify it, a unique key, and some value present in it. Let's say the first record has a value of a and a key of 1. The second record has a key of 2 and a value of p, and so on. We have how many? 50 records. Fine. There can be different values inside our key. Okay. So now what direct address table tells us that the keys are nothing but representing the arrays because they are unique. So they are representing the index of the array. So it is 1, 2, 3 and so on. Fine. So they will be representing the index of the array and the values inside of it are representing the keys. So on. Fine. So the direct address table says that since the keys are unique, we will be just finding out the maximum key and this key will become the size of the array. This much big size we will be declaring the array with, and each key will become the index. Okay, each key will be behaving as an index and its value inside the index element. This is what direct address table tells us. Now if we want that key value 8, okay, what is the value present at 8? So we will just directly go to the index 8 using the random access method property of array. Okay, as soon as we reach 8, we will see whether a value is present inside of it or not. If it is present, we will return that value. It is direct, simple, using direct address table. Okay, so for example, if we have an array 1 1 1 2 3 4 5 6 6 7 and we want to store the frequency of each element. So 1 is 3 times, 2 is 1 time, 3 is 1 time, 4 is 1 time, 5 1 time, 6 2 time and 7 1 time. So this becomes our keys. These becomes our keys and the frequency of each element becomes the value present inside that particular index. Okay. So in that scenario, we can use direct address table. So what is the disadvantage of direct address table? So arrays we already know. Okay. And it's quite simple. So the insertion here is direct and the searching here is also direct. Fine. So what was the disadvantage? The disadvantage was, let's say we have a mobile number. Okay, a 10-digit mobile number. How an array will be created for that? Or we have some values, let's say 1 2 3 4 5 6. These are the keys. These are the keys. Okay, and these are my values. So just for 3 values, how much big array should we need to create here? So just for 3 values, we need to create an array of size 10 to the power of 6 plus 2. This much big array we need to create just for storing 3 values. Correct? So therefore this was the disadvantage. Just for storing these 3 values, we are creating such a big amount of array. Okay, so this was the disadvantage of direct address table, but yes, this is used especially in competitive programming. Okay, frequency array is a type of direct address table. We are going to see now a code in which an array will be given to us and we need to print out for each element what is its frequency. In that, the direct address table will be used. So before just going to the code, how an element becomes an index, so it's very fine. So if we have an array and it is 1 1 2 3, okay, so this elements needs to be the index. So inside a frequency array, what we will be doing, we will be accessing this element. So now when we access this element, what is array of 0? It is nothing but 1. So this 1 becomes the index of my frequency array. Correct? It's that simple. Now for this to reduce, we will be using hashing that we'll be seeing in the next video. Now in this video, let's see the code. Let's see a question that given an array, we need to find out the frequency of each element and print that 1 is coming this many number of times, 2 is coming this many number of times. Okay, a simple direct code. Let's see that. So let's see the implementation here. So in this, an array is created. It has 15 elements and these are the elements. Now we need to print out that 1 is coming how many number of times, 2 is coming how many number of times. So we create a frequency array. Okay, so that frequency array need not be the same size of the array, it can be the maximum element present in the array. So let's see the implementation now. Now here we have an array. Okay, it contains all these elements. Then we are declaring a frequency array. Its size need not be 15, it can be the maximum element present in the array. Okay, now we simply perform this loop. Fine. Now in this particular loop, this loop will running for the array size because we need to access each and every array element. This array element will become the index of the frequency array. So as we can see, I is 0. When I is 0, array of I is nothing but 1. So now frequency of array of I will become frequency of 1, and at index 1 in the frequency, the value will be incremented here. Now at index 2 in the frequency, because array element is 2, the value will be incremented. Then at index 3, the value will be incremented. Okay, now array 1 comes, element 1 comes again, so from 1 it will be incremented to 2. Fine. So this is how the frequency array is being created. Now when the frequency array is completely created, after this what we are going to see, these all elements, that 1 is coming 2 times, 2 is coming 3 times, it will be printed out. Okay, so frequency of 1 is 2, it is printed. Next, frequency of 2 is 3, frequency of 3 is 3, frequency of 5 is 2, then 9 is 2, 10 is 3, and so on. That it is complete. So for all the elements, the frequency is now printed with us. So this was an implementation of direct address table and it uses the same concept. Again, frequency array is used in competitive coding. Now what we will be saying is the disadvantages we have already seen of this particular direct address table. Fine. So we will be seeing the hashing part in the next video. Thank you.